evenings really is just an amazing thing. So we know that you're going to find it was time well spent. Annalise Record is one of my favorite human beings and one of my favorite math celebrities. She's a consultant who we're just very fortunate to be able to work with. You're going to learn a lot from her. She does PD independently. So if you work for a district that's looking for great presenters and great teacher professional development, I'd highly recommend reaching out and making contact with Annalise. She's just a fantastic well of information and knowledge. So with that, I'm going to hand it over. I'm going to thank Annalise for taking the time to presenting with us. And just like everyone else who's joined the webinar, I'm excited to just kind of listen and learn.
Great. Thank you so much, Jan. I appreciate that. Welcome, everyone. I'm thrilled to be with you here tonight. I live in Concord, New Hampshire. Weather has been gorgeous lately. It's been just sunny and warm again, so it's been wonderful. So we have, Brainingcamp brought me on board to do some trainings for their customers who had bought the Brainingcamp app because they wanted not only to help people understand the manipulatives and how to use the program, but also like the mathematics behind it. So how do we use these manipulatives to help move our students forward on their math journey? And I love manipulatives. I mean, research has shown how powerful they are to have that concrete, pictorial, and abstract exploration of number concepts and find the patterns within our number system. And so when I discovered Brainingcamp, I was so floored. In fact, Cuisenaire are my favorite manipulative. And Brainingcamp has the best app that I've seen for them. It's just incredibly powerful what you can do. And you can do things with them virtually that you can't do them with them physically. So it's not a matter of should we use hands-on or virtual manipulatives. It's both of them. Both of them work so well together for us to have our students explore these math concepts. So Dan had the idea of having some webinars that also focus on content. And so it's not just the app, but also what can we do with the app? So I thought for our first one, hopefully the first of many, that we'd begin with addition. The operation of addition. And I want to be able to go through the progression from kindergarten to 5th grade. Now, I was a 5th grade teacher for 13 years, and then I became math coach K5. And when I became math coach K5, my world opened up because I had no idea how to help students learn about numbers, what a 5 was and what that quantity meant, which meant I had to go on my own learning journey to learn early numeracy. It is a whole world unto itself. And I want every 5th grade teacher to understand the expertise needed for early numeracy. And I want every kindergarten teacher to know what they're building for the 5th graders. And so I want you to see that entire progression tonight. So let me just get started here with my slideshow for you. And then we'll get into the app. So yes, I want to go over addition today. I'm going to go through concepts of addition that form the foundation of it from kindergarten up to grade 5 tonight. So it's a lot. It's going to be an hour. It's going to be a full hour for sure. Dan mentioned that I am an independent consultant and I do a lot virtually because having lived in Northern New Hampshire for so long, we were a tiny mill town and loved my colleagues there. But I also found an online community of math educators that I could talk about this passion I was developing with math. And so I've developed Facebook groups and I facilitate some. I facilitate one on Math Running Records, which is a fluency-based group, and then Build Math Minds for Christina Tondevold. She has her own membership site there. So you can feel free to reach out to me at any time. You can email me, or I'm also active on Twitter. On Facebook, that growth mindset tree, I post only math posts. So feel free to join me there. For participating tonight, you will be able to get a code that allows you 45 days of access to Brainingcamp for you and your students for 45 days. But you do have to redeem it today. So the code is the record add. So you can feel free to do that. I wouldn't have you do that right now because I want you to sit back and relax. And in fact, tonight, I want to focus on the mathematics and not the app itself. You will see me manipulating the objects, but I want to talk about the math. Right? The more we can understand the math ourselves, the more we can help our students and unlock that journey for them. So I want you to sit back and relax tonight. I'll be sharing with you the development of mathematical reasoning. Pam Harris is a consultant, and I just love her graphic that I'll show you about the development of that. So I want you to gain appreciation for that. And I also want you to see how Brainingcamp, these virtual manipulatives from Brainingcamp, will allow us to help our students become procedurally fluent but through conceptual understanding, how we can help that deepening understanding for them. So I want you to sit back and relax. This recording will be emailed to you, so you don't have to worry about taking too many notes. I'll be giving you also a link to a Google Drive document that you're able to have moving forward as well. So just sit back and relax and enjoy the journey of addition. So we're going to be going through kindergarten through grade 5. So I'm going to begin with counting and cardinality. We'll go into basic facts as we move into grades 1 and 2. Then doing the multi-digit work that will lead them toward the algorithm, but honestly, the algorithm doesn't have to be the end goal. There are other invented strategies that might even get you there faster and really build the kids' number sense. So, and finally, I'll be showing you that application of the same strategies that work for basic facts work with decimals and fractions. And so I want you to see that application. And then of course, we'll have questions and answers as well. Dan is manning the chat bar. So if you have questions during the seminar, you certainly can ask them there. I won't have my eye on that though. I'll be, presenting here. So Dan can either interrupt me if he feels I should answer a question right away, or we'll save those for the end of today. Now, there are just a few foundational ideas I want you to understand before we get going today. First of all is the progression of our children that research has shown of students as they are on this journey of mathematics. So if I ask a student 3 plus 2, they're going to begin by putting out probably fingers or objects to show a 3 and a 2, but they're going to begin by counting all. So they actually, get that on camera, they'll have to be going 1, 2, 3, 4, 5. So they actually put out the amounts of both groups and count them all starting at 1. Now that progresses to counting on. So they might say, this is 3, 4, 5. That progresses to they do it in their head. You can see them bobbing in their head, 4, 5. That then progresses to using derived facts. So if we haven't given the time to build that flexibility, we've asked the students to go right ahead to learn them all. They miss that derived strategy phase. And that's the phase that allows our students to unlock their number sense and their conceptual understanding. So I want to show you tonight how these manipulatives can help us with those derived strategy phases. Now, this is based on Dr. Nikki Newton's work. A lot of my consulting work also is on Math Running Records, which is an interview talking to our kids about their thinking that can transform everything. And then this one graphic here by Pam Harris. She has a site called mathisfigureoutable.com that, we all can learn and grow with mathematics. We all can learn this and everything we can figure it out. There's no kind of secret or magic to it. And so look at this progression of the K-12 math journey of our students. Students begin their math journey in in the counting phase of reasoning. It might be in kindergarten and it might not, right? These phases are not locked into a grade level. They're on the children's brain. So counting strategies begin with counting and cardinality. Typically, it's the world of content for kindergarten. As students move into grade 1 and 2, typically, we want to help move them into additive thinking. That's what the whole night tonight is going to be on. But you can see that multiplicative reasoning is the grades 3, 4, 5. So if you have students who are doing multiplication math facts, and they're skip counting, that's additive thinking. They're in a previous phase of reasoning within the context of a different content. So tonight we'll be focusing on students who are in the counting phase of reasoning within addition problems. We want to help move them into the additive thinking. So that forms a foundation. And just lastly, I want to talk to you a little bit about word problem types. We do want to explore mathematics with context. So important for our students, and research has been done, particularly this cognitively guided instruction by Thomas Carpenter and his colleagues, that have isolated different problem types that involve addition and subtraction, just even single step. And these problem types remain the same all the way through the grade levels. So I'll be showing you examples of that tonight. But I want you to think about the number of problems, word problems you could think of right now that involve single step adding or subtracting. How many would you say? How many problems would you say you could write for me that involve addition and subtraction single step? Oh, I'm not able to see the chat bar. Dan, would you mind chiming in what you're seeing in the chat bar?
Yeah, not seeing much yet either.
Okay.
If everyone, when they use the chat bar, could you, by default, Zoom sets it to just panelists. If you could change that to all panelists and attendees, that way we can all chat with each other. We definitely want to hear from you. So please go ahead and make that change. There we go. Jill, thank you. Thousands. Wow.
Well, I told you to sit back and relax. Maybe you're taking me seriously at my word, which is totally fine. But I will share with you that typically, now I don't mean how many problems could you write for me, but there's a certain type of problems with a structure. And very often what I see when I'm presenting in my district presentations is like 2, 3, or 4 that you could write that has a certain structure to it. So let's go through just for a second what these are. The add to problem type involves action that is increasing objects over time. So you get a beginning part of your story, then a change happens that increases that amount, and you get an amount at the end of the story that's larger than what you started with. So for example, there are 3 birds in a tree. 2 more flew into the tree. How many are there now? But the thing is that since there are 3 parts to that story, any of those 3 parts could be the unknown. This gets into sophisticated stuff, right? So that's one problem type, the add to problem type. The take from problem type is what you typically think about for a subtraction, that we have a beginning amount, a change, and an ending amount. But this time the beginning amount is more, right? We have some objects that get broken or eaten or given away, and the amount at the end of that story is the result, which is less typically than what we started with, right? We also have put together take apart where there's no action happening, but there are categories. So if I have, let's say, 3 bluebirds and 2 chickadees in a tree, how many birds? So I'm joining those groups together, but there's no action. No birds flew in or flew out of that tree. And then finally, we have the comparison problem type. Typically, comparison is introduced in grade 1. And then in grade 2, there are 3 harder versions of them. But it would sound like you have there are 5 bluebirds and 3 chickadees in a tree. How many more bluebirds than chickadees? That kind of a thing. So there are actually 15 problem types. A lot of my consulting work is on this as well, because until we understand all the problem types, it's very difficult for us to help our students to explore those. So as a foundational piece then, for the formation of addition, putting it into context, as well as the progression of what students will do as they are going through the journey of the mathematics. I'm going to show you, get into the Brainingcamp site. Now, very often as we're doing trainings, and I do also trainings for Brainingcamp customers about the apps and the manipulatives. As we are doing this, hang on a second, I'm always asked about the sharing feature. How do we actually use this with our students and then we can have that be shared back and forth with the teacher. So I want to show you something that I created tonight to kind of help facilitate my presentation tonight, but also maybe a possible way that you organize this yourself. So all that I did was there is a sharing code that's available in all of these apps, and that code will bring your student right to that app, and whatever you have on the screen when you press share, that will appear. So I was finding as I was doing my presentations that I wanted some of these things already on the screen. I didn't want to take time from the presentation to drag manipulatives in or have some, a problem at the top of the screen. So I began developing for myself a list of share codes. Now, these share codes will not expire. So I'll have these forever. And as a classroom teacher, once you create a share code, if you begin keeping track of those codes, you'll have them in future years as well. So I just showed you this. I will give you this document. I'll put a link to this in the chat bar. Just remind me to be able to do that, but you'll have this sheet that'll have all the examples I'm using tonight. And so you can move forward with those. So I'm going to be showing you the share feature essentially through my being able to do a presentation. So I want to begin talking to you about counting and cardinality and what are we looking for with counting and cardinality. So I had a code that I created. All I'm doing is putting it right down here. So in the main Brainingcamp screen, in the bottom, it says share code. I'm just going to paste that code right in there. That's how your students will do this as well. The access that you have as a teacher matches what the students will see. So this is exactly how they'll do it. You just say go, and it's brought you into the app I was in and what I had on my screen when I pressed this button. So you'll notice this button here that says share. All I did was I went into this orange, get my link or code, and then I pressed this button here to copy this code. That's all that I did. And then I copied it into my Google document, which you could work collectively, collaboratively with colleagues in your school to kind of develop a set of codes and tasks. But what I wanted to talk to you about here, counting and cardinality, is typically when we ask students, we were trying to find out whether they can count. I know for myself as a fifth grade teacher, I had no idea the expertise needed for early numeracy. So I thought that if you had asked me what I was looking for students when I asked to find out whether they can count, I would put out some cubes and say, can you figure out how many are there? And I'd watch the students doing that. Now, I originally thought that would involve, well, I need to know one-to-one correspondence, right? I need to know that I'm going to count each one only once. And when I'm doing that, I do want to make sure they're saying the numbers in the correct order, because I could be counting these 1, 5, 7, 2, right? So it would be out of order. But there's so much more we could be looking for. So what I typically do, this is an assessment that I do with some kindergarten students. I put out 8 cubes like this scattered. I ask them how many. When they are counting out how many, I am listening for saying the numbers in the correct order and the one-to-one correspondence. And then when I'm done, I say to them, how many are there? That's called cardinality. The knowing that the last number said is the quantity that is there. And there are students who will recount them. They don't yet have the understanding that the last number that they said is the quantity that is there. So that's your first kind of telltale. After they're done counting, they go 1, 2, 3, 4, 5, 6, 7, 8. You say, how many are there? And see if they tell you. Because the students who have developed that will look at you and say, 8, like I just told you that. But the kids who have not developed that yet, they will recount them. So then what I do is with my fingers, they can tell I am not adding any or taking any away. And I'm going to put them into a straight line, the same number. Now, this is called conservation of number. The idea that I have an amount on the screen, I can rearrange them in any way that I want, and there's still 8 there. So I put them into a straight line and I say, how many are there now? But they can tell I haven't added any or taken any away. And then there are students that will recount them. Of course, the students who have developed that sense will say, there's just 8. They're not going to recount it. It's not very efficient when you know there's 8. But there are students who don't yet know that conservation of number, that I can move objects. This is going to help us in the context of when we're working on 10 frames and figuring out addition or subtraction, the idea that I can move objects around. I'm not changing the total amount. I have that flexibility of thought, and flexibility is going to be the key for us. So at that point, then what I do is I go to the next screen. The next task that I have them do is I would use this. I'm going to give them I usually do this in person, but what I do is I take those cubes away. Now, you'll notice here in the app that there are 2 buttons. There's a Brainingcamp symbol, and then this one that says apps. They bring you to the same place. They're just bringing you back to the main app screen. And again, all I'm going to do, put in the code I created down here under the share code. Any of you that are joining in later, you'll get this document. So you'll have these codes tonight. I give them 6 more cubes, and I put them in a straight line this time, but I ask them to begin counting in the middle one. And so I've had students, they'll go 1, 2, 3, 4, and they stop. They don't go back and get the first 2. They haven't yet figured out that they have to get all of them. I also have had students that will go 1, 2, 3, 4, 5, 6, 7. So they do one twice. So for those students, I want to make sure that they're moving them as they count them. A kindergarten standard in many of our states is to be able to count up to 20 objects arranged in a circle. So if they don't move them to keep track of what they've counted, they're going to go around and around that circle, and it can easily make a mistake, right? So that counting and cardinality piece then is super important for our youngest kiddos, and to be aware of that on the progression. And one last thing for counting and cardinality is the idea that they need to be able to also produce that amount. So it's not just I give you objects and you tell me how many are there, but they're going to be a bunch of objects, and I'm going to ask you, can you give me 5? So what I did here was I brought out several of these squares, and I brought out what's called, this kind of grouping symbol. So it's a little symbol right down here in the bottom right. I clicked on it, and then I was able to adjust the size of it. I do want to mention to you that at the moment, you'll notice when I click over here on one of the manipulatives, there's a little menu. I can copy it, I can delete it, I can change the color. But if I click on this guy, it's not going to go away. So what you can do is you draw a rectangle covering the entire thing, then you'll get your options and you just delete it. So if you ever bring out one of these, a 10 frame, an array, or that grouping symbol, and you want to get rid of it, just highlight over the entire thing, and then you'll be able to do that. So the producer then, students can move the 5 objects over. Now, all of that is a preface, right, to our addition. So let's get into the addition right now. Moving into certainly kindergarten, first grade now, going to be adding within 5, adding within 10. So what I have for you here is a story problem, because we do want to explore these in context. We're not just wanting to have numbers by themselves. We want to be able to have the context, and that's actually going to affect how they solve them. That cognitively guided instruction, that research showed that students figure out these problems in different ways because of the story structure. So Kylan had 3 pairs of shoes. Her grandmother had bought 4 more pairs of shoes. So how many pairs of shoes does she have now? So a student might then, all I did was here, I brought out a 10 frame by clicking this really bottom button right here. And I'm going to drag over, well, let's see, Kylan had 3, and you can either drag and drop, or you can, once you place one, you can just click on it. It's going to intuitively know where to put it. So those are the 3 pairs of shoes that she already had. And then her grandmother bought her 4 more. So she physically has more shoes at the end of the story, which makes it an add to problem type. It doesn't make an addition, it makes it an add to problem type. And the result is the unknown. How many does she have now, right? So at this point, when your students are telling you how many there are, you've got to ask them, how do you know? Because you're going to see the students on this progression. Some students will count up all the squares starting at 1. They're at counting all. Other students begin with the first addend, and they begin with 3, and they go 4, 5, 6, 7. Other students know they can start with a larger addend and count on from there. So that's a great telltale. Oh, 4, 5, 6, 7. But other students are going to do this. They're going to say, well, I know 3 and 3 is 6, and 1 more is 7. So I know it's 7. I use a 3 plus 3 to help me. This is the heart of the derived strategies. They'll be forwarding all the way through the journey. Another student might say, well, I know 4 and 4 is 8, and it's missing 1, so it's 7. Another student might say, well, I know I can move one of these, because if I know I can move them around and not change the total amount, I can rename 4 plus 3 into a 5 plus 2. That's easier for my brain. And yet another student might say, well, if the whole thing was filled, it would be 10, and it's missing 3, so I know it's 7. You've got to talk to the kids about their thinking. You've got to have them share with you what their thinking is, and then you'll be able to get into their brain to see where are they in that progression of counting on, head counting, and then those derived strategies, right? So incredibly powerful being on that journey. And then I want to talk to you about, I want to also show you down the very bottom, there is a count button, and it will tell you how many are there. So you'll be able to see that. And then I want to show you an example of decomposition, because if we want students to develop flexibility within 10, yes, they're going to be counting on, but we don't want them staying in the counting on phase of reasoning. Very often our kids are staying in counting, and we want to help move them forward into additive thinking. And the heart of that for developing that fluency within 10 is decomposing numbers. So here you have an example of, there are frogs and ducks on a pond. If there were 7 animals, what are all the possibilities? So what I'm going to do is I'm going to bring out 7 of these squares. I'm going to go to the count down here. Typically, I like to change the benchmark every 5, so students can supertize and tell at a glance how many are there without having to count. Again, it's all about moving them past counting. Kindergarten, that is the world. No problem at all. Grade 1, they're in transition. By grade 2, I want students moving past the counting on, right? And counting. I want to move them into the additive reasoning. So I know I have 7 right now. Well, what I can do is, now that would be if there were 7 frogs and no ducks, but it did say that there are some of those. So let me do this. I'm going to say, well, what if this guy was the duck? So I could have a possibility of 6 frogs and 1 duck. What I can then do is I can copy this, and I can change this guy again. It could be 5 frogs and 2 ducks. And then I can copy again. So you get the understanding here that I can systematically go through all the possibilities to break apart that 7. And that way I will know that a 5 and a 2 and a 4 and a 3 and a 1 and a 6. So I can use that, as you're going to see in a second, with my larger facts and even multi-digit numbers, fractions, and decimals. So I would build this entire decomposition board, and the students are going to notice a pattern. They're going to notice as one number is going down, the other one's going up. And so really important patterns our students are noticing. So all of that sense of foundation, we need all of that in place to move then into our teen numbers for addition. So at this point, I want to make sure I'm talking to you about the difference between strategies and models. So I've heard them and I've used them myself interchangeably, but there is a difference between strategies and models. So strategies are what we do with the numbers, how we can break them apart, put them back together, use doubles to help us, those kinds of things. Whereas the models are how do we make that thinking visible? And that can be concrete, like Rec and Recs, 10 frames, Cuisinart rods. It can be pictorial, as we draw pictures, or we draw pictures of Rec and Recs and 10 frames. And it can be abstract. I could write an equation. But so how are we making that mathematical numbers that I did with the numbers visible? So here I'm showing you a Rec and Rec. I'm able to choose how many rows that I want. So those of you that might be working with upper elementary students, you can use this for multiplication. It's one of my favorite tools for multiplication as well. So I chose to have 2 rows. You notice that there are 10 and they're color coded at the 5. Hugely important to build number sense. One of the critical pieces is using the benchmark of 5 and 10. So if I'm asked to figure out 6 plus 7, there are students who will count up all the beads, others that will count on. But the heart of this is to be able to work on the derived strategies, and doubles tend to be used a lot by students. And so if I know that this is 6 and 6, and that's 12, so I don't have to, sorry, I meant to drag the pen. I think my Zoom bar is covering the bottom of the screen. So if I want to, if I know that this is 12, I don't need to count, right? It's helped me move past that. So I know that the 6 and 6 already is 12. It's just one more for 6 plus 7. And so that what I'm showing you here is the idea of a doubles plus 1. I also could think of this as being, well, if I know 7 plus 7 is 14, 6 plus 7 is 1 less. So I can use my doubles and near doubles. And I'm modeling this for you on a Rec and Rec. But I could show you that strategy with Cuisinart rods, or I could do 10 frames, right? So it's the mathematics of breaking apart the numbers to facts that I know. That's your strategy. Your model is how do you make that thinking visible? And so now I want to show you when we get into teen numbers again, because this strategy of doubles, we tend to do this a lot in America, whereas other countries actually don't emphasize doubles as much as we do here, because the most powerful one is bridge 10 strategy, because that can get forwarded to the nearest 10, the nearest 100, and the nearest 1,000. So what I'm going to do, and nearest whole, fractions and decimals. So what I'm going to do is I'm going to change this to be 1 row, and I'm going to, let's see, I think I can get rid of those here. Just going to delete these titles here. I'm going to go to this 20 beaded row. So in Brainingcamp apps, on the bottom right-hand side, you have a little arrow that shows you different work mats, and different apps have different mats. So in the Rec and Rec one, you can either have the basic, which is 1 row of 10 to each row, and you can do more rows by over to the left, choosing how many rows that you want. But I just chose this work mat of 20 beaded row, because if I want to show you 8 plus 5, I can slide over 8 in one swipe. I don't have to count those one by one. I know this is 8 because I can subitize. My brain can tell that this is 3. Our brains can tell how many at a glance are there without counting, up to 5 objects, even as adults. And so the color coding of the 5 helps me. I can tell that that's 8. I also can subitize this little bit of 2. And I know they're color coded with the 5, so that would have been 10. So I can slide over from here over and know that it's 8. Now I want to add to it 5 more. So I'm going to slide them over. With Rec and Recs, the beads that are in play are the ones on the left. And you do have some things you can press over here to kind of cover up the ones not in play, either opaque, so it's totally covered, or transparent, or just not there at all. But I want to be able to know how much this is, right? So I'm going to click on this button. And this is like a part total, right? They're going to show you that this is 8 and this is 5. But watch what I can do. I can move these 2 from that 5 to join the 8 and rename it as 10 plus 3. That's the most powerful strategy that we have. We're going to use Bridge 10 for both addition and subtraction, and that will transform your students' work with multi-digit work fractions, and decimals. Now I'm taking my time to get going here because the more we do the foundational work, the faster we'll be able to go in the upper grade levels because the thinking is the same. If we slow down a bit, we can go faster later. Our students will understand conceptually what's happening. So once again, what I had was I slid over 8. I want to add 5 more. So I grabbed those. But now as I bring it over, I want to show you how 2 of that 5 can join the 8. I can rename 8 plus 5 into 10 plus 3. And that is going to be the heart of the strategies that I want to be able to show and moving them forward in our journey. So let's go on into double digit work now, right? Let's think about how we can apply some of this thinking to double digit work. So as we move into end of grade 1, we're doing some double digit work, and certainly in grade 2. And so I want to show you adding within 100, and I'm going to use Cuisenaire rods. Cuisenaire rods are my absolute favorite manipulative, and because they help us move our students from the counting phase of reasoning into additive thinking, and from additive thinking into multiplicative, and multiplicative into proportional reasoning, like all the way through their journey. It's the most powerful tool in my mind. So Pam earned $35 babysitting. Darcy earned $23 more than Pam. How much did Darcy earn? This is a comparison problem type because I have the amount that Pam earned, the amount that Darcy earned, and a distance between those two. And then this comparison problem type, in this situation, the larger amount is the unknown. I know the amount that was the smaller amount, which is Pam's earnings, because it said that Darcy earned more than Pam. So Darcy is the larger amount, and I know that this is the distance between the two. So, and I can use that in a part-part whole diagram as well, very where tape diagrams and the bar models as well. But let me just show you how we can add the 35 and the 20. So with Cuisenaire rods, if you're not familiar with them, I do want to show you there's a color coding system to them. So first of all, this is trademarked by Hand to Mind. Hand to Mind is a phenomenal hands-on manipulative site. Handtomind.com, and they own the trademark on the color coding here. So the 5 and the 10 rod are color coded like a sun, like they're hot colors. So that's 5 and 10. In fact, actually, let me just turn on, I'm going to turn it into, no, I don't want the words to go away. So 5 and 10 is your benchmark. Then the 2 rod, you can see that these are actually all in centimeters. So they match the size of your base 10 blocks. This is worth 2 of those cubes. And then if I bring down the purple and then I do the brown, this is your 2, 4, and 8. These are your warm colors, and they're doubling. 2 doubles to 4, 4 doubles to 8. Then we have the 3, 6, and 9. So your multiples of 3. These are like cool colors, like the ocean. And then we have 1 and 7 kind of being in their own category over to the side. So this color coding system will help your students and yourself remember the size of the units of the rods, because they've got color, and then they also have length, width, and shape when you have them physically in person. But here on the in the virtual screen, they're matching those same units as well. Now I want to be able to show you. Let's add these two together, right? So down below, I can choose to have them come out horizontally or vertically. So I'm going to choose vertically. So I've got 30 and 5, and then I've got 20 and 3. So I'm going to slide these over. You also can highlight groups of objects and slide them together. So I have 23. Now, typically what we've done with base 10 blocks is these are all ones cubes, and you can't subitize beyond 5, and kids leave them scattered. Well, if they have 8 or 9 and they're scattered, you can't tell how many there are without counting unless you arrange them. I do have students, when they draw pictures of base 10 blocks, put them in subitizable patterns. I tell them, I don't want to count them. Show me in groupings how you can show me how many there are so I can tell at a glance how many they are. But one of the strategies we can use for this is to add our 10s together and add our 1s together. So what I'm going to do is I'm going to arrange my 10s and put them together. And then I'm going to also put the 1s together. But you'll notice here that I'm going to rotate it, like seeing it horizontally. Now, this is different than if I had 8 cubes sitting there, the kids are going to count. And they're probably starting at 1, right? But this manipulative can help kick the kids' brains into a strategy. I can begin with 5 and think 3 more. right? And then there's a self-correctingness to it because your 8 rod matches the distance. Here's your part total amount, right? A fact family, a 5 and a 3 together make an 8. And if I have done decomposition activities enough that I've broken apart an 8 over and over again and know it could be a 7 and a 1 and a 6 and a 2 and a 5 and a 3, I know the 5 and a 3 make an 8 and I don't have to count on. At this point, I have an equal trade so that I know that my total amount must be 58, right? I've got my 50s and I've got my 8 more. Now, and then what I would want to do is I would want to record this as partial products. So I know many first and second grade teachers do double digit work with students, but I implore you to not go to the algorithm. It's honestly, it's in the core standards in grade 4 as a traditional algorithm for a reason. It limits our students thinking, well, I'm hoping to show tonight, do you see the power of this? But if you have to do the algorithm or line them up like this, at least have your students record it as 2 partial amounts. We can retain the place value understanding, right? Too often the kids end up getting wrong answers. They don't understand what they're doing because the place value is not attached to it, right? So we can at least, if you must, do it in that vertical way, having them record it as partial sums. So let me just show you what happens when we need to do this kind of addition and it bridges a 10, okay? And how the Cuisenaire rods help that transition happen. So let me just change this text. When you share a share code with someone, it then becomes editable. So if you share a share code with the students, every student gets their own copy of that task. So no one's going to be seeing anyone else's work. They would need to share it back to you once they're done, to share what's on their screen at the time they hit that. But so all I did was just tweak that a little bit. So I have a structure of a comparison problem type, and I have the larger amount is the unknown. I can change the details or I can change the numbers a little bit. Let me show you this 35 again. So I've got 10, 20, 30, and I have 5. And then I'm going to have my 28 this time. And I'll just slide them over like a group. I do want to add my 10s and 1s together. So I'm going to slide those over again. And as I turn these horizontally, this is another button you get within this app. I'm going to show you that linear distance here of that 8 and that 5. But look what I can do. I can bring a 10 over. And then I can say, well, that bridge 10 strategy. I can break apart that 5 into 2 and 3. Because I can rename 8 plus 5 into a 10 plus 3. I can break apart that 5 to give it to the 8 to rename it as a 10 plus 3. So again, this is because I'm using this manipulative, is kicking our students' brains into using a strategy and not counting, right? And in fact, I would not attach that 10 rod to the 5 I already have because I want students to be able to visibly see, oh, that's a 60, sorry. So I would want to have 5 here, right? And then I would want to have these 20 over here. Or did I do the wrong amount at first? Say 50. No, it should be 63. Yeah, so she's 63. I think I did an extra rod. Sorry. But so I want to be able to have the 5 as a benchmark visually to see, right? So with this then, I now want to show you other strategies because it's not just about the algorithm. Let me show you the power of this. And then we're going to be able to apply this to fractions and decimals as well. So I'm going to go into this time. I want to show you the, here we go. There are other strategies we can use for addition as well. It does not have to be just getting to that algorithm. So if I have, let's say 48 plus 19, what if I just gave it to the students horizontally and asked them, how many? How many do you think? Have them tell you, these are called a number talk. Where you have one expression and you ask the students, what are you going to do with it? You can't use paper pencil. You can't write anything down. You can't go to that algorithm. What are you going to do, right? Now I've chosen my numbers carefully. For the round and adjust strategy, that works really easily when either of our add-ins is close to the nearest 10 or the nearest 100 or the nearest whole all the way through the journey. So if I want to do 48 plus 19, what I could do is I'm going to bring down a pin to mark the 48 spot. So you'll notice here that in the pin, it shows you the value of what it's on. I'm going to want to see this 19. If that were 20, that would really help my brain. So why don't I make it be a 20? That'd be easier for my brain because I could do 48 plus 20, that's 68, right? But I'm not adding 20, I'm adding 19, which is one less. So I can make it go back one. So this is my strategy. I'm rounding and adjusting, but my model to show you this thinking is a number line, an open number, this kind of a number line. So I know my answer is 67. Again, I started on 48. I added 20 because 19 is pretty close to 20. And then I came back one because it wasn't 20 I was adding, it was 19. Okay, so the strategy is to round the number and then adjust after that. Makes it easier for our brain. And I'm modeling that for you, but pictorially here and a little bit abstractly. Number lines are pretty abstract on here. But what if I do it another way? So what if I just delete that away? And because 48 is pretty close to 50, right? So what if I put a pin on 50 and 19 again is close to 20? So why don't I just go 50 plus 20? Because that's not hard for my brain, right? And so now I'm on 70, but I rounded up 2 from the 48 and 1 from the 19. So if I come back 3, won't that be the same? And then I can also do my pin to get to that answer there, right? So I got to this in a different way. But it's a little more attainable for our kids. If you think for a second, if I were to write this on a board for your students and ask them to solve it, and I write it in this way, I want you to think about what they're going to do. Right? The algorithm is basic facts, and that's it. You don't have any place value inherent with it. They're going to do 8 plus 9. How many of your students know 8 plus 9 is 17? And if they don't know it's 17, I mean, many will, but those that don't know it, what are they going to do? They're going to fall back to what's familiar and comfortable, which is counting on. They're going to start at 9. They're going to count on their fingers, 8 more. The fingers don't bother me at all. What bothers me is they're in the counting phase of reasoning, right? I wouldn't want to count on 8 without using my fingers. How else do you keep track of that much, right? But the idea is the students are in a counting phase of reasoning in the context of a double-digit addition problem, let alone 3-digit and multi-digit in grade 4. We have 6-digit numbers. If their basic facts are not having flexibility and strategies, they're going to be counting on. They're being held back in the counting phase of reasoning, right? So this is very different. This is retaining the place value, understanding is being flexible with numbers. And again, this strategy, you wouldn't want to do it for every set of numbers you're given because these are just work really well because they're close to the nearest 10 as they would to the nearest 100, nearest whole. So another strategy students could do, because there isn't just one, again, it's building that flexibility of thought for them, would be adding on one of the add-ins by chunks. And maybe I'll do it by place value position. So I'll show that to you again here. But this time I'm using the open number line. This is within the number line app. You'll see you have a mat for basic when we first came in. Then you have decimals and fractions and this open number line. So what I chose to do is I typed in this box. When you click on this box, you're able to just type in whatever number you want. So I made it be the 57. What if I want to add 30 and then add 6? Well, these buttons over here to the left, if you do the 3 buttons on top, you then get every option within that range. So you have the range of 1s, 10s, and 100s. I want to add 30. So I'm going to click above the plus 10, and now I can choose the plus 30. And automatically it's going ahead the 30, and I know it landed on 87. Well, I'm not adding just 30, I'm adding 36. So in that case, I'm going to go back to my screen left here. I'm going to choose those 3 buttons above the plus 1, and I'm going to choose plus 6. Now, as I do the plus 6 here, your students might not yet know. They might count on that 6. So what can I do instead? Well, I could do 3 more. If I know 7 plus 3 is 10, then 87 plus 3 gets me to the nearest 10. And then all I have left is 3 more if I have decomposed a 6 enough to know that 3 and 3 makes a 6. Well, then I can do 3 to get to the 90 and 3 to get to the 93. This is all going back to our foundational K2 work, right? The beginnings of decomposing numbers and using that nearest 10, that bridge 10 strategy. Doubles is not going to help me very much in this context, right? So that's one strategy you can add on by a place value. And there's one more strategy I want to show you with addition, which is to decompose and make a friendlier number. Now this comes into play when you have the bridge 10 strategy that I showed you, where you break it apart to make the nearest 10. Does that work with larger numbers? Is it limited to just the basic facts? Well, if I were to ask you to ask your students 98 plus 57, and this actually happens in my presentations as well. I ask people 98 plus 57. And because our minds go to the algorithm, because it's how we learned, we want to line them up and think, well, 8 plus 7 is a 15. I can regroup that one, right? We go into that cycle of the algorithm, and our students do the same thing. They feel like, since that's the only way they can solve it, if they have not been given the opportunity to think flexibly about numbers, they want to go to the algorithm, which very often, again, is counting within that. Well, 98 is pretty close to 100, right? What if I broke apart 57 into 2 and 55? Can I do that? Can I break apart numbers like that? And what's the benefit for that? Well, doesn't the 98 and the 2 make a 100? And so I've renamed it to be 100. Hang on, 100 plus 55. Well, that's easier from my brain, right? How can I make that thinking? So this is kind of an abstract model of this. Let me show it to you pictorially here. And if I had a 100 beaded rec and rec, where you can do one straight line of beads that are 100 color coded every 10, you could show it concretely as well. But so I'm starting on 98. I want to add 2 more, because I do want to show you where that comes in here. 98 plus 2, I land on 100. And now I want to do 55. Now you'll notice above each of these icons here, you're limited to the multiples of 10, but there is this button here. And this button is going to allow me to be whatever I want it to be. So when you click on that, you can do this calculator, set the value, and I want it to be 55. And now here you see that representation, 98 plus 2, I made it to 100, plus 55, I made it to 155. And that actually is the answer, 100 plus 55, right? 155. So that strategy, these 3 strategies, the idea I can add one of the add-ins on in chunks that are easier for my brain. I can break apart one of the add-ins to make it a new expression that's easier for my brain. As well as the rounding and adjusting, those strategies come into play whether we're doing multi-digit work, decimals, or fractions. So you can see how the work with these computations can become a little faster when the students have the foundation for that. So let me just show you for a second here. I know the algorithm is in your lives. So let me just show you how the Brainingcamp app is special in its use of the base 10 blocks as well. So what I'm going to do is going to go to that share code here again. If any of you come in late, I'll be sharing with you that Google document that has all these codes in it. So you can begin using these codes and just tweak them to however you want. Once you have that code, it's yours to do with whatever you want. And then you'll have to share it again. You'll get a new code to be able to share that with your students. But so if I showed you 188 plus 144, you can in this app be able to choose how many place value positions you want. I just have it here with the 4 place value positions. And what I did is I chose the background mat of addition. You do have basic place value factors, comparing and subtraction as well, but I just chose here for the addition one. So you can see how we're adding these 2 amounts together. Well, I might want to start adding with my hundreds place. I don't have to start in the ones position, right? And then so I have my 200s. Now these look like they might even be more than 10 to make another 100. Now, if you highlight them all even, you can press, you can be sliding them over a place value and it will automatically group them for you. So it took what it needed and it spit back what it didn't. So these 2 were not combined. I actually had highlighted them all. And so it regrouped 10 of them, leaving 2 behind. So I'm going to scoot those down to the bottom here. And similar here with the ones. What I love is how when the ones cubes come out, when you're dragging them down or you click on them, they show a 10 frame. Because again, kids need to be able to subitize, otherwise they're going to be counting. And so certainly with using ones cubes, that can be pretty unmanageable. If you have 8 cubes and 9 cubes and you got a pile of 17 of them, the kids are going to count out 10 to trade it for a 10 rod, and then they have some left, but they're just doing a whole heck of a lot of counting. So I'm going to highlight 10 of them. And you can choose to group them yourself. If I had moved them to this column, it would have done it automatically. So it's up to you, however you want to do that. And then I would just slide down those. So I know that my total amount is this 332. And so the place value, again, this is leading the kids toward the algorithm to understand why it's happening, which is super important. I know some states, like Nebraska, the standard is in grade 2 to do the standard algorithm, that traditional algorithm. I just implore you to also, if you need to do the algorithm, because it does limit the kids' thinking, just don't spend any more time on it than any other strategy, right? I mean, it is one way of doing it. But again, it's kind of giving the illusion of understanding if students can do that and not understand what's happening there. Now, just for our last 10 minutes, I want to share with you how this can apply toward fractions and decimals, because the same thinking applies. We don't have to go through procedures of like add numerators and keep denominators the same. We can actually be a lot more flexible with our thinking. So first of all, I just want to mention to you that when we do get into fractions, there's some conceptual understanding that we need to have. And that's the understanding in grade 3 that fractions are made up of unit fractions. So that the fraction has a numerator of a 1. So that 3/4, we want to be able to call it 3/4, but also call it 3/1/4, right? The kids can understand that a 3/4 is a whole partitioned into 4 equal sized pieces, and we have 3 of them, and the name of each of them is a 1/4, right? So it becomes writing it as an addition sentence, that 1/4 plus 1/4 plus 1/4 makes 3/4. Now, in the next grade level 4, that formally becomes 3 times 1/4. They're used to multiplications being repeated addition. And so they think of it being 3/1/4. This is what happens in grade 4. As you can see here, using the fraction tiles, they match the physical ones that you have. I'm in the number line background page, and I was able to bring down 3 of the 1/4 pieces. The kids can visually see that 3/4 is worth 3 of the 1/4. Really huge piece of conceptual understanding before we get into our work formally with the fraction. So let me just go back to you for a second. I'm going to show you some addition strategies as we finish up our time here today with the fractions. So still here in the fraction tiles, Delia had 4/6 of a yard. I do want to mention to you that I created this by using the text bar. So the text bar allows you to type in text, but the text bar does not allow you to type in fractions, having that horizontal line. And I like students to see it like a horizontal line and not a slash mark, like when you're typing in a Word document. So I actually created this myself by putting a text bar that said Delia had. Then I made a text bar that said 4, a text bar that did this line, and a text box that did the 6. So I created that to make it look the way I prefer to have the students see it. But take a look at this. Delia had 4/6 of a yard of striped fabric and 3/6 of a yard of polka dot fabric. How much fabric does she have in all? The structure of that goes right back to kindergarten level part whole with a total unknown. I have 2 different types of something, and I'm joining those 2 groups together, right? The structure of the story problems stays the same. And all happens is the numbers become multi-digit or fractions and decimals, or they become multi-step. They combine these different basic 15 story problem types to be combined with the 9 that there are in multiplication and division. So, so if I'm going to be solving this, then Delia has 4/6. I'm going to bring down 4 of the 1/6 pieces. And then I'm going to bring over 3 more. Now you'll notice that my number line right now has denominators of 8. Well, that doesn't help me. I'm working with 6. So down below here, oh, let me get rid of that text bar. Down below here, these arrows allow you to change the denominator sizes. So I'm going to change it until it's at 6. And now you can see it exactly matches up. And so I have 4/6 and I have 3/6. Well, what would happen if I broke apart this 3/6 and gave 1/6 to the 4/6? Can't I rename that as, oh, sorry, I'm going to give 2 6 to the 4 6. So can't I rename that as 1 and 1/6? That's very different than adding numerators and then having to remember not to add denominators and then feel weird because you went over your numerator is has a value more than your denominator. We want to call them improper, which actually they're not called improper anymore because they're just fraction form and mixed number form. It just happens that the value of it is greater than 1. But so I can rename 4 6 and 3 6 in that decomposition to rename it to an easier expression. I know in my classroom, I did a lot of concrete pictorial work, but I only did it with the procedure as the goal to add numerators, keep denominators the same. I know I did not do this kind of work. I hadn't known about it yet. Dr. Maya Angelou says that we do the best we can until we know better. And then when we know more, we do better, right? And so what I know now is that flexibility of the thought is so important. So again, having this number line and I can just change the size of the denominators, it's incredibly powerful, right? That you can't do as easily in person when you have these concretely. And lastly tonight, I want to show you about the Cuisenaire rods again, because the Cuisenaire rods are the best manipulative. That's my opinion. But let me show you how Cuisenaire rods can be used with fractions in pretty sophisticated way here with this particular version of the app. What I've built for you here is a decomposition house for the whole, but you're able to change the whole. Now think back to beginning of addition, beginning tonight. We had those linking cubes. They were a collection of ones. We then took the 7, I forgot the context, but there was 7 and we tried to think, well, it could be 6 and 1 and 5 and 2 and 4 and 3. It's identically parallel to fractions and decimal work. The very same strategies I shared with you tonight can be used with decimals and fractions, retaining that place value understanding and building their number sense. So what we can do is we can decompose the whole into its pairs of addends only in the fraction language. And I chose to do here this 8 rod because we don't just want to decompose 5 and 10. We want to make sure we're decomposing 5, 6, 7, 8, 9, and 10. So these rods can be used for whole numbers. You'll notice actually in the bottom right-hand corner, you have just them plain, that's basic. You have them with whole numbers and it will label them for you. Your decimals will be labeled or the letters of the colors or these fractions. Now, what I've done here for you is showed you this decomposition house, right? Well, I can right now choose to make the whole, let's say, be 4. They all change to be relational, representational of what they are. Plus, the benefit is that these rods allow the students to see these existing as a group, right? So the fraction tiles are awesome, but if I want to show 7/8 with fraction tiles, I'm showing it as 7 1/8, which is awesome for our grade 3 beginning learners. But now I want to move into this additive thinking with fractions and have the 7/8 actually exist as a group. They're also fabulous for multiplication, right? Because the Cuisenaire rods, they exist as a group. So can we use these then to do another addition problem? Now I want to show it to you an example of a decimal and the difference that it can make. So let me just go back out and share this. And again, I'm putting it in context. We want to explore mathematics with our students in context, not just computational calculators with numbers, right? We want to be able to have a kind of context with it. So Sue ran 8/10 of a mile to get to a store and then 5/10 of a mile to get to the park. How far did she run in all? Now you can think of this as being an add to problem type because she physically ran some miles and then she physically ran some more. There's action, right? And so I have this 8/10 of the mile and 5/10 of the mile. I labeled these for you. These are the decimal ones. You can see, you can choose to, so you have these here. And then let's say I want to figure out how much that is, right? Could I think about rounding and adjusting? Well, 8/10 is pretty close to a whole. So I could think of it as being a whole plus 5/10. So that would be, that's 2/10 too much, right? So I can come back 2/10. And if I know that an 8/10 and a 2/10 makes that whole, I know I must be at 1 3/10, right? Then I can, another way I could think about it is what if I think about, well, in my 8/10 is 5/10 and a 3/10. So if I think about exchanging that 8/10 for these 2 rods that exactly match it. What's the benefit of that? Well, a half and a half is a whole. So it's a whole and 3/10, right? So that's round, that would be decomposing to find a friendlier one. And lastly, I can do a bridge 10 strategy. I can think about 8/10 just needs 2/10 more to make a whole. And so I can break apart my 5/10 into 2/10 and 3/10. And so I know my total is 1 and 3/10. That's very different than what my 5th grade students, a handful of them, when I taught them the procedure of lining up decimal places, I knew I still have a handful of kids who tell me the answer was 1300ths, right? Because it made no sense to them. It was just basic facts and lining up a procedure. But when we explore the meaning of the 5/10, the idea that I can break it apart and have that flexibility, if I've broken apart a 5/10 into a 1/10 and 4/10 and 3/10 and 2/10, it just opens up the door and provides much more access to more of our students. And just lastly tonight, I just want to show you the mixed numbers as we're dealing with, as you're dealing with different denominators in grade 5, of course, you may want to just convert them to common denominators, and then you can be doing these kind of flexible strategies. I prefer not to go into the whole improper, well, the fractions greater than 1. I prefer to kind of have this number sense with it. So if I have 2 2/3 and I'm adding to it 1 2/3, can I round and adjust? Sure, I'm going to put a marker on 2 2/3. I chose in this number line fractions version to have my number line go from 2 to 5, just to make that kind of little window. I'm on 2 2/3. If I want to add 1 2/3, well, that's pretty close to 2 whole, right? So if I keep going until that says 2 wholes, I'm landing on 4 2/3, but that was 1/3 too many. So I'm going to come back a third and I land on my 4 1/3. So that might speak to me as a student. I might say, well, it's pretty close. I want to round this guy. But another student might say they have a different strategy and modeling it here on the same model of a number line. Maybe they add on by place value. So I'll start on 2 2/3. I'm going to add 1 first. And you can see when this shows that the distances of 1. So I'm on 3 2/3. And then I want to add the 2/3 more, 1/3, 2/3. Now I've arrived again on my 4 1/3. And finally, we have the decomposing to make a friendlier number. This 2 2/3 is only 1/3 away from 3. So if I place this on the 3, if I place this on this 2 2/3, I can break this distance apart into a 1/3. So I know I'm landing on the 3. And what I have left is a 1 1/3. So I want to slide that till it shows 1 1/3. The 1 1/3 plus 1/3 makes 1 2/3. And again, I've landed on my 4/3. But I was able to represent that thinking to you on this number line. So here you have 3 different strategies, 3 different ways I'm playing with the numbers, but you have this one model of a number line. So that was quite the journey. That was quite the journey of the adding in of addition from kindergarten to 5th grade. I'm going to grab the link to that document that I promised you, so you have those codes right away to begin working with. I'll put that in the chat bar for you. And I'm certainly happy to answer any questions that you have. I've not been able to see the chat at all, so I have no idea what's been happening in there.
Well, Annalise, I mean, I can, for one, can say that covering addition over about a half dozen grade bands is pretty ambitious, but you pulled it off.
I did it in an hour and 2 minutes.
Incredible. But yeah, that was absolutely wonderful. I learned a ton. One of the things that I absolutely love about manipulatives is how open-ended they are and how there's so much you can do with them. And I've stared at these manipulatives all day, every day for years, and just watched you do things that I'd never thought can be done or never thought of doing with manipulatives. And that to me is half the fun of using manipulatives. And I would encourage everyone out there too, just to keep playing, keep learning, keep experimenting with manipulatives. There's so many wonderful ways to take these abstract concepts that kids struggle with and make them visual and make them meaningful. So from me to you, I think from everyone in the chat box and watching at home, to you as well, that was special and fantastic. And I know that I'm sure it's late. We understand there's people who probably need to get to grading or family or whatever you do. But if anyone feels like hanging out for a little bit longer, I know Annalise is the type of person who always likes to chat just a little bit more and
Talk
answer any
math with
questions.
anybody at any time. That's very true.
All right, well, we had a couple of webinars last week, and we have those recordings ready, so I can paste those in the chat box. And this recording won't be ready until maybe sometime tomorrow, but when it is, we'll email it out. We'll try post it out and send it to everyone.
Awesome. So you can feel free to put any questions that you have in the chat bar if you'd like. So the video from tonight will be emailed to you. Hopefully by tomorrow that will be emailed to you.
Annalise, some people are also asking whether they can get a copy of that Google Doc somehow.
Yeah, it's right in the chat bar. I know that the chat bar is, I'll put it right there, in there again. So Cuisinart rods, they really are my passion. And I've created 2 online workshops. So if you go to my webpage, annaliserecord.com, you can, number one, I have 3 Padlets of resources for you for elementary math, one based on fluency, one based on problem solving, and then one on the content standards. But if you go on my website, there is a page for my online workshops, and I get a Cuisinart rod K2 and a Cuisinart rod 3.5, as well as fractions essentials. And the new one I just released last week is place value K2. So you're welcome to check those out. I also have a document of getting started with them that are on my Padlets. So if you sign up for my Padlet, it's just a website of free resources. You can download the about a 5-page document introducing Cuisinart rods to students and using them. So the site is annaliserecord.com. Yeah, don't let your fear of them get in the way of getting them into the hands of the kids. That's what I always tell everyone, because I meet so many teachers who tell me, oh, I have them, but I don't use them because I don't know what those numbers are. Let it be part of the journey with you and the kids, because it's so powerful. You can use them for everything from kindergarten through high school. I don't know if there's a way for you to save the chat.
Yeah, I wish we could too. I think we're going to send you the link, and if there's any way for us to capture the chat and keep the chat, we'll send that too.
Yeah.
Oh, someone's suggesting you just do a Control A and copy and paste everything from the box.
It's really, it scrolls so
seem to
much
work.
that would be hard to do.
Yeah.
But certainly on the document, that Google Drive document that I shared, those are all the share codes I used tonight to facilitate that whole journey. So that may, oh, Susan, I'm glad you enjoyed Cuisinart rods. I know, they're so powerful and versatile.
Okay. Yeah. All right. I think, yeah, I think someone's saying Zoom does save the chat, but I think you're right. It's maybe just saves it as a separate file. So it probably is there. Yes, we will record this. We'll send out the link to everyone. If you want to find out about more webinars, follow us on Facebook, follow us on Twitter. If you want to see what Annalise is up to, follow her on her social too. Check out her website, annaliserecord.com.
And I see in the chat bar someone had asked about math running records. There is no cost to them. They are available for free. It's a research-based protocol by Dr. Nikki Newton. They're on her site, mathrunningrecords.com. And then I facilitate the website, Math Running Records, in Facebook, where I share, there's hours and hours and hours of videos. In fact, I have I'm happy to share with you a link to the Padlet that I have for that. Well, actually, if you go to my website, annaliserecord.com, and sign up for my fluency Padlet, all the information that's on the free Facebook ones on there. I have my own consulting ones because that's part of my consulting work, is to train people. Because as you can tell, there's nothing elementary about elementary math, right? So getting the protocol sheet to interview kids, you really need to know the background of all the information. So I do that kind of training a lot now, but it really is my way of helping people understand early numeracy, which is so important. But they're a free recording sheet. There's no cost to it. Dr. Nikki wrote the book called Math Running Records, published by Routledge.
Okay. Well, I said thanks to Annalise. I want to thank all of you for taking time out to come and watch. We know that this is not an easy year, not a normal year, and to be able to give another hour of your time after teaching all day is really an incredible commitment and says a lot about you as teachers and your commitment to your students. So thank you. We look forward to hopefully doing many more of these. And once again, Annalise, thank you so much.
Thank you so much. And thank you all for all that you're doing for your kids. And I do hope you get some time for yourself. I know that's easier said than done with your families and your students, but thank you for all that you're doing. So appreciative. You're changing the world, helping your kids out.
All right. Well, stay safe, stay well, everyone. We look forward to seeing you again soon.
Take care.
Have a good night.